if you're given the slope, and instead of the y-intercept, one of the other points on the line, you can use the slope-intercept form, which is what again? What is our slope-intercept form? What does it look like? What does it state? 3 days up, and look at what's happening. Slope-intercept form. Something to help you. I am not going to be your brain. Thank you, Macy. Thank goodness for our Macy this morning. Y equals mx plus b, slope-intercept form. We're going to be learning another form starting tomorrow, so you better get this one, or not, I don't think it's tomorrow, I think it's Wednesday. But you better get this form down, because now, remember, we have standard form, which is what? How does standard form go? You can say it with him. ax plus by equals c, yeah, that's our standard form. Y equals mx plus b is slope-intercept form. In a couple of days, we're going to learn another form yet. So you need to start getting these memorized so that when you're told which one to use, you can pull it out, okay? So we're going to write the equation of the line whose slope is -4 and has this ordered pair -1, 3 on it. How do we know that -1, 3 is not the y-intercept? How do we know that? How come we can't just pull that y value of 3 out of there and say that's the y-intercept? Benton?
Because the x-intercept has to be 0.
Because the x value, not the x-intercept, but the x value of that point has to be 0. So if this was ordered pair 0 something y, then we would know it was the y-intercept. But it's -1, 3, so we know we don't have the y-intercept. So what we have to do is we're going to identify the things we do know so that we'll be able to put them into our slope-intercept form and find the y-intercept so we have our equation. Okay, so y is what? We have this information right here. We have this information, y is 3. M is? -4. X is? What? I can't hear you. -1. And b is? We don't know. Right? We don't know that right now. That's what we need to find. So we will take those 3 pieces of information that we do know, and we will substitute in for that 4th piece of information that we don't know. So we will put 3 in for y, -4 in for m, -1 in for x, and leave b. Go ahead, get that solved for b, because you know how. Solve that for b. I get -1. What about you?
Yes.
Yes? You agree? So the y-intercept is -1. What does that mean? It is what? What would this graph do? Well, it's going to fall from left to right because it has a negative slope. What else will it do? What else do we know for sure? Did we just find out? What's the y value versus across the y-axis? -1. And ordered pair -1, 3 should be on our line. Okay, let's write the equation of our line. What's the equation of the line that has this slope of -4? We now know it has a y-intercept of -1. We just happen to know that ordered pair -1, 3 lies on it. What's its equation in slope-intercept form? Y equals x, and we don't replace the y and the x because there's several ordered pairs on this line, remember, but between any 2 points, the slope is -4. That is not going to change. What else is not going to change? The y-intercept of -1. We know the y-intercept is -1. We know that the slope is -4, and we know that any ordered pair that is substituted into that to make it true is also on that line. Let's clean that up. Y equals -4x minus 1. Now, I say let's verify it with a graph. So in other words, what I want you to do, remember we were given this information that we had ordered pair -1, 3. Let's verify that we got the right y-intercept. Because if we have a point and we have the slope to make other points, we should be able to make the line of the graph. Okay, so let's do that. Let's put our -1, 3 on the graph. Ordered pair -1, 3 is right here. And let's use our slope of -4. What are the two ways we can use that slope? -4 over +1, meaning we'll go down and right. Or what's our other choice? You'd think I was paying BC or something, because she's doing so well. Okay, 4 over -1 means we would go up 4 and left 1. Okay, so go ahead and make 2 more points besides that one using both of those directions, okay? And then, of course, you need a ruler to draw a straight line because the ruler is your straight edge. Everybody except Colin, it appears, needs a ruler. Anybody else have a ruler already? Okay. Always have to draw lines. Okay, some of you are still not heeding my instructions which say draw the line all the way through the coordinate plane. Don't be stingy. Send it all the way through. Okay, first of all, do we like the behavior of our line? Yes, why? Because it's had a negative slope and it should be falling from left to right, and it is, correct? Okay, why were we were verifying that we got the right y-intercept. Is your line, look on your papers, is your line crossing the y-axis at what? What's it supposed to cross at? -1. Is it crossing it at -1? Yes. Yeah, it's crossing at -1. In fact, it happened to be one of the points we ended up making to help us get our line, didn't it? When we used the slope. Okay, so what if we had used another point? Pick another point that's on that line other than the one that we used to start it and the y-intercept. Pick another point that has integer x and y values so that we can verify that it does not matter which point you use. If it comes from that line, same line, they that line has one equation. That line has one y-intercept. So somebody give me another ordered pair name. How about this one? What's this one's name? What's that one's name? -2, 7? Okay, let's use that one. -2, 7. What if that's the point they had given us instead, along with the slope of -4? Should we still get for B -1?
Yes.
Yeah, let's make sure that we do. Let's just check it out here. So remember, we have our this now is our x and our y. We know what our slope is. So what are we going to put in for y? 7. Remember, we were checking out a different point. How about m? What are we putting in for m? -4. What are we putting in for x? No. -2. We're taking that point, a different point that's on the line, and the slope, and verifying that, you know what, it doesn't matter which point you use along with the slope in your slope-intercept form, you should get the same b value. So plus b. Solve that equation for b. On your paper, solve that equation for b. You get -1? So how many points does this line have? An infinite number of points. It really has an infinite number of points. We really only need to know one point though, and the y-intercept, and we can write the equation of the line. Okay? Or we can, if we know 1 point and the slope, we can write the equation of the line. Or if we know 2 points, we can write the equation of the line. Because what can we do when we're not given the slope? How can we find the slope if we're given 2 points? What do we do? What if they give us 2 points but don't give us the slope? We did this back on Friday. Yeah, we got to use the slope formula, don't we? So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Find the slope. Use the slope in one of those points, and you should be able to then find the y-intercept, which would help you write the equation of the line. Okay, so let's go to the back side now, and let's do an application problem. We have a caterer that charges a $200 fee plus $20 per person served. So how many times do you think they charge the $200 to you? If you hire this catering company, how many times? One time, yeah. They say, you know what? Just to have me cater, I'm going to charge you a one-time fee of $200. And then another $20 for every person that I prepare food for. Okay? Write an equation that represents the cost. This is important right here. The cost as a function of the number of guests. In other words, which one's the independent variable in this situation and which one is the dependent variable? Got it, Tim?
The independent variable is the number of guests, and the dependent variable is the amount, is the total cost.
The total cost, yeah. The total cost is dependent upon function of the number of guests. The number of guests is controlling the situation. So if you don't want to spend a lot of money, you don't invite too many people. If you don't care and you want to, make it look like you're having the party of the century, then invite as many people as you want. The number of guests controls the total cost. So now that we've decided that the number of guests would that be our x or our y then? What would that be, our x or our y? Number of guests, it's the controlling one, it's the independent. Is that the x or the y? Really? This is sad. It's the x. It's the x. So the number of guests is our x value, and the total cost, we're going to say right here, is going to be our y value. Y is a function of x. It is dependent upon what happens with x. So what would that equation look like? Given that they're going to charge a one-time fee of $200 and $20 for every guest, every person served, what would our equation look like? Go ahead, write one on your papers. I'll give you a little hint. Slope-intercept form is what it'll be in when you write it. If you want to make it the easiest way to write it. Slope-intercept form has the dependent variable by itself. It says, I depend upon this happening to x. That's what slope-intercept form is. Okay, so what is the equation for this line? What is the equation for this situation? Eddie, what you got in your paper?
Y equals 20x plus 200.
Y equals 20x, did I hear, plus what?
200.
Plus 200? How many of you want to agree with Eddie that that's a good equation for this situation? Yeah, that's what we all should have. Y, the total cost, is dependent upon taking 20 times the number of guests, add that $200 they're going to charge you one time, and you have your equation. Okay, now go ahead and graph it. So you know what the slope is from that equation. You know what the y-intercept is because you know where they're at in that equation. Now, here's the thing though. We have to be really careful here. And I know some of you have already started graphing this, so it'll be interesting to see what happens. When you are graphing slope, remember, when you have a whole number, what can you put a whole number over to get your run? Because you only have a rise right now. What can you put it over? 1. So we have a rise of 20 and a run of 1. That's 20 what? Dollars and 1 guess, right? Okay, so when we go, first of all, would you just go and finish numbering across here? Go ahead and finish this part. Because it's kind of interesting what happens here. Now we have to be careful. scale that they're using on these axes? Is it 1? And what's the x-axis going by? 5s. What's the y-axis going by?
Hundreds.
Hundreds. So can we go, so does that mean then that we're going to start at 200, when we put our first point at 200 here? Because that's the y-intercept, that's our starting point, right? Does that mean then that we're going to go up 20 grid lines and over 1?
No.
So what should we do? You have to multiply by 5 and add 200? Okay, that's the starting point, but so in other words, you're saying we should take this times 5, just the 20 times 5? If we do something to a fraction, don't we have to do it both up and down? So if we take this times 5, we have to take the denominator times 5? So, pardon? No, because if we just multiply by 5 over 1, we're now changing the slope. We can't change the slope, we can only rename it. If we take it times 5, we're making the slope 100. Now we're saying it's $100 for every guess. We just need to rename it. So when we rename it by multiplying both up and down by 5, what's 5 over 5 equal to? 1. What happens when you multiply something by 1?
It's the same.
It stays the same, it stays 20. So we're really not changing its value, we're changing its name. So its new name is 100 over 5. Which means then we need to write $100 for every 5 guesses and run 5 guesses. So in reality, we do start at 200 still, so the plus 200 that Macy talked about, we do start at 200. From there, we're going to go up $100 and over 5 guesses. That's only 1 grid line up and 1 grid line over. We're going to go up $100 and over 5 guesses. No sense to go down $100 and over 5 guesses to the left because we'd have a negative number of guesses then. So this is a ray one again, not a line, not a full line. So now take your ruler and draw, well, I just undid my, I don't want to erase, I want a line. So now take your ruler and draw a ray going through your graph to represent having this party catered at $20 a person and a one-time fee of $200. Okay? Now, what else did it tell us to do? It said, graph the function and describe what the slope and the y-intercept represent. Well, this is going to be pretty easy, isn't it? What does the slope represent? Let's write it out. The slope is what? What is that, 20? Yeah, fee per guest. Fee per guest. That's what it's representing. That's what it's telling us. It's telling us how much you're paying for every person that they feed at this function of yours. Okay, the y-intercept is, well, our y-intercept is 200. So what is that 200?
Base.
Pardon? Base fee. Yeah, it's like the startup fee or the base fee. It's a one-time thing that you have to pay, but oftentimes that's what you have to do. You have to pay something just for them to do it, to have their services, and then there will be other costs. Okay, now it says in C, find the cost of catering an event for 200 guests. Well, this right here says we're putting it in for X or for Y? We're putting it in for X. This is our X value. So we're going to take our equation we wrote, y equals 20x plus 200. We will substitute in, because if you want to try and use your graph to find this information, are you going to be able to? Does the x-axis go out? Do you want to make this graph go out to 200? No, it's a lot easier to do it algebraically using the equation. So we will substitute in 200 for our x value. Lots of 200s going on in this problem. How much will it cost you to have 200 guests? Apparently you're popular.
So 20 times 200 is how much, first of all? 4,000. So now the startup cost, the base fee is looking pretty cheap. It's the 4,000 for feeding all the people, that's the expensive part. It's 4,200 what? Dollars. We need a label on that. We know that that is the cost for having 200 guests at this function. Now, what if you only have, let's say, $1,000 to spend? Do you have a loan?
In trouble.
No, I'm saying, what if it's like, you only have $1,000 to spend, I guess I can't have all 200 people. How can you figure out how many people you can have? What would you do? You only have $1,000. Where are you going to substitute the $1,000 into the equation? In for the y value, and then solve the equation for x. How many people you can have? Okay, how many people can you have? Anybody get that math going up there yet? Take 200 away from 1,000. That is 800. Divide that by 20. That is 40. You can have 40. You're going to cut your cost down immensely. Okay. Anybody have any questions? Okay. Then you need to get out a sheet of loose leaf paper to show your work on for this worksheet.